Rational number. We are going to discuss about rational number. Any number that can be expressed in the form of m by n, where m and n are integers and n not equal to 0, is called as rational number. The set of rational number is denoted as q. Thus, q is equal to m by n, m and n belongs to z, and n not equal to 0. Z means the set of integer. There are a few examples of rational number here. First one is 1 by 3, where the value of m is equal to 1 and n is equal to 3. From this we can easily say that m and n is integer which belongs to the set of z and n not equal to 0. So it is a rational number. Five is also a rational number, as 5 can be represented as 5 by 1, where m is equal to 5, n is equal to 1, as 5 and 1 both belongs to the set of z, means set of integer, and n not equal to 0, so it is a rational number. Where m is equal to 7, n is equal to 2, both belongs to the set of integer, n not equal to 0, so 7 by 2 is also a rational number. So from the example we can come to a conclusion that 7 by 2 a terminating number which is a rational number, 5 a whole number, a integer, is also a rational number, 1 by 3 a non-terminating number which is also a rational number. There are a few theorems on number system. If I square is divisible by p, then I is divisible by p, where I is a non-zero integer, p is a prime number. Some example like if I is equal to 9 and p equal to 3, then I square means 81. If 81 is divisible by 3, then will 9 be divisible by 3? And it happens. The second theorem is if I1 into I2 is divisible by p, then either I1 or I2 is divisible by p, or I1 and I2 both are divisible by p. But I1 and I2 are non-zero integers, p is a prime number. One example like if I1 is equal to 8, I2 is equal to 5 and p equal to 2, then I1 and I2 is divisible by 2 and I1 is divisible by 2, but I2 is not. Example of theorem 2. Example 2, like I1, if the value of I1 is equal to 9 and I2 is equal to 6 and p equal to 3, then I1 into I2 is equal to 54 is divisible by p. And also I1 and I2 both are divisible by p. Like I2 is divisible by p, as value of I2 is equal to 6 and I1 value is 9, it is also divisible by p. Theorem 3. If I to the power n is divisible by p, then I is divisible by p, where I is a non-zero integer, n means a positive integer. If the value of I is equal to 4, n is equal to 3 and p is equal to 2, then I cube means 64 is divisible by 2, then I means 4 is divisible by 2. Is root 2 a rational number? Okay, let's assume root 2 is a rational number. So root 2 can be represented in the form of m by n, where m and n both are integers and n not equal to 0. And m and n have no common factor except 1. M by n's whole square is equal to 2. Now m square is equal to 2n square. Here the right hand side is 2n square, which is divisible by 2. That means the left hand side, which is m square, is also divisible by 2. If m square is divisible by 2, then as per theorem 1, where m is the integer, m is also divisible by 2, as 2 is a prime number. So from this we can prove that m is divisible by 2. Now let's assume m is equal to 2k. Now 2k's whole square is equal to 2n square. Now 4k square is equal to 2n square. Now 2k square is equal to n square. Here we can see that the left hand side 2k square is divisible by 2. So will be the right hand side, means n square will be divisible by 2. As n square is divisible by 2, as per theorem 1, n will also be divisible by 2. So m and n both are divisible by 2. That means both have a common factor 2. But this one contradicts our assumption, as our assumption was that m and n have no common factor except 1. But we get here common factor as 2. That means root 2 is not a rational number, means which cannot be represented in the form of m by n. That means root 2 is an irrational number. We have already discussed a lot about irrational number like root 2, root 3, but still we missed some of the irrational numbers. What are the other irrational numbers? Cube root of 2, cube root of 7, etc. these numbers can't be expressed as cubes of any rational number. Such numbers are called as surds. There are few properties about surds. What are the property? Nth root of A is a surd if 1. A is a positive rational number. 2. If n is a positive integer, means n greater than 1 and n belongs to Z. Third one, if nth root of A is not a rational number. Representation of surds. 1. Nth root of A can be represented as A to the power of 1 by n. 2. Nth root of A to the power of 1 by n is equal to A. Nth root of A into nth root of B is equal to nth root of A into B. Nth root of A divided by nth root of B is equal to nth root of A by B. Here n is greater than or equal to 1. Rationalization. Multiplying a surd with another surd to make it a rational number is called as rationalization. Like 5 plus root 3 is a surd. Now to make it a rational number, we have to multiply it with 5 minus root 3. 5 plus root 3 into 5 minus root 3 is equal to 25 minus 3 is equal to 23. 23 is a rational number. This process is called as rationalization.